So, what is object-oriented programming and why should you learn it? Well, just like we have different ways to bake a cake, we also have different ways to write software. These are called programming paradigms. So, a programming paradigm is a way of writing software. Now, we have many different programming paradigms, such as procedural, functional, object-oriented, event-driven, and many, many more. Out of these, functional and object-oriented programming are the two most popular paradigms these days. With each paradigm, we think of building software in a different way. For example, in functional programming, we build software by creating and composing functions. In object-oriented programming, we write software by creating objects rather than functions. Now, each paradigm has its pros and cons and should be used to solve certain problems. So there is no such a thing as the best programming paradigm, just like there is no best way to bake a cake. But every now and then, you might come across someone like this guy. You've probably seen him before. His name is John Smith. He's a developer with very strong opinions. He's obsessed with functional programming and believes it's the only way to write good quality software. But a wise software engineer uses the right tools and techniques for the right job. So in a real application, we can use multiple paradigms to solve different kinds of problems. So these paradigms are not mutually exclusive. Now, C++ has strong support for object-oriented techniques, and a lot of C++ applications and frameworks are built this way. So as a professional C++ developer, you need to have a solid understanding of object-oriented programming. And that's what I'm going to teach you in this course. In object-oriented programming, we build applications in terms of objects that work together to solve a problem. Each object has a clear responsibility, just like people working in an organization like a restaurant. An object is a software entity or a building block that contains some attributes or properties, as well as some functions or methods. A good example is a dialog box. A dialog box has attributes like size and position on the screen, as well as functions like show, hide, resize, and move. Another example is the video player you're using right now. A video player has attributes like size, current position, and playback speed, as well as functions like play, pause, stop, and so on. Now, these two examples are about things we can see on the user interface. But objects are not always about visual things. In a real application, we have tons of objects that power the user interface. We have objects for storing and retrieving data, sending emails and notifications, performing calculations, and so on. Now, to create an object, we need a class. A class is a blueprint or a recipe for creating objects. So just like we can use a recipe to bake many cakes of the same kind, we can use a class to create many objects of the same type. Now, we can represent a class using a visual language called UML, which is short for Unified Modeling Language. In UML, we represent a class using a box with three sections. On the top, we have the class name. In the middle section, we list the attributes or variables that hold data. And in the bottom section, we list the functions. These variables and functions are called the members of a class. Now, with this class, we are essentially defining a new data type. We can do that using structures as well. You learned that in the previous part of this course. But quite often, we use structures as simple data containers and classes for creating objects that can do things. So structures are more about data, whereas classes are more about data and functionality together. So a class combines data and functions that operate on the data together. This is one of the core principles of object-oriented programming and is called encapsulation. So encapsulation means combining the data and functions that operate on the data into one unit, which is a class or an object. Now, the terms classes and objects are often used interchangeably, but technically speaking, they're different. An object is an instance of a class, okay? All right, that's enough theory for now. So next, I'm going to show you how to define a class in C++.